All right, I'm going to run through the 4.4 notes and practice that should help you on the homework. All right, so starting with question 1, we're solving for the variable y, and it has to be a real number. Okay, this is just solving equations, so just using inverse operations to get y, to solve for y. So here we have the square root of y. That's the only operation for y on this side, on the left side. So in order to get rid of that square root, I'm going to square both sides. So square one side and square the other. So on the left side, that's just going to become y. And on the right side, that's going to become 36. So there you go. And then you do the same thing for part 2. Square this side and square this side. On the left side, you're going to get x. On the right side of the equation, you're going to get 49. For question 3, so solving this right here, now we have more than just the square root. So I can't subtract because we have to use the order of operations in a reverse sense. We have to solve for y. So we're going to subtract 16 first. So subtract 16, subtract 16. And then you're going to get the square root of y plus 12. That's going to be equal to negative 8. Now, this is going to be a problem here. So because we have the square root on the left side and a negative number on the right side, so maybe even up here you might have gotten one with a negative on the right side. So if you have a negative on the right side with the square root on the left side, your answer is going to be no solution. So no solution, because when solving equations, for y, we're only going to include the positive roots, I guess you can say. So I guess what we're saying here is that whenever I take the square root of this number right here, so whatever y equals, so, well, I guess you could say if you were to solve this, like, so let's say that you square both sides, you get y plus 12, and negative 8 squared is going to be 64, and then you subtract 12 and subtract 12, and so you get y is equal to 52, right? So they aren't going to count this as a solution, even though kind of if you plug this into the equation, you're going to get the 52 plus 12. 52 plus 12 is going to be 64, and you take the square root of 64, and this is where it's kind of weird. So the square root of 64 is positive 8 and negative 8, but they only, Alex, I guess it's hard to explain, that we were only going to, the solutions can only be from that give you positive roots, yeah. So the solution can only give you positive roots, not negative roots. So that's why we're going to say this is no solution right here. So no solution. So keep that in mind as we're solving these right here, and there should be a couple more. So for question 4, we're going to add 1 and add 1 here. So we're going to get the square root of x minus 10. That's going to be equal to 5. Now this is okay. We have a square root on the left side, a positive number on the right side. That's fine. And we're going to square, and we're going to square. We're going to get x minus 10 is going to be equal to 25. Subtract 10, subtract 10, and we'll get x is equal to 15. We're going to add 10. That makes more sense right there. Sorry, let me go back a little bit. We're going to add 10 and add 10. And we'll get x is equal to 35. There we go. That will be our solution. All right, for question 5, same process. We're going to add 2. So we're going to start with constants. We're trying to get the radical by itself, essentially. Then we're going to get 3 is equal to, I got to sneeze. Square root of 5e minus 16. And then we'll square both sides. We'll get 9 on the left side, and then we'll have 5e minus 16 on the right side. Then this is solve it like a linear equation, so we'll add 16 and add 16. what does that become? 25, I think. So we get 25 is equal to 5v. We'll divide both sides by 5. And then we'll get v is equal to 5. For 6, same deal. We'll subtract 5 and subtract 5. We'll get the square root of 2v plus 11. That's going to be equal to -3. Now this is a problem. We have a square root with a variable in it equal to a negative number. So this means that we're going to have a no solution answer. No solution. Okay. All right, question 7. We have a radical on both sides, which is fine. We're just going to square both sides to get rid of both of the radicals. So we're going to square the left and we're going to square the right. So that just means we'll have 6u minus 15 equal to 4u plus 7. And then we're going to solve for u. So I'm going to subtract 4u from both sides. And then I'm going to add 15 to both sides. So on the left side, we should end up with a total of just 2u. And on the right side, we'll have a total of 15 plus 7, that's going to be 22. Then we'll divide both sides by 2, and we'll get u is equal to 11. For 8, now this one right here, it's equal to 0. What we'd want to do here, rather, because we do have two radical expressions, do what we have up here. So move one to the other side, and then it will just look exact and just be similar to the one that we just did. And so we'll have the square root of 9v plus 2 equal to, so I'm going to add the square root of 6v plus 11. So we're basically just taking this whole negative term, moving it over to the other side. So then we have the square root of 6v plus 11. Then we'll square both sides, just like we did from the previous example. So then we would have 9v plus 2 equal to 6v plus 11. I'm going to subtract 6v from both sides and subtract 2 from both sides. So on the left side, we should just have 3v, and on the right side, we should just have 9. Then we'll divide both sides by 3, and we'll get v is equal to 3. For 9, all right, so this one is going to be a little bit different because we have a variable on the left side and a radical on the right side. Now, it's not really going to be too different for the first step. We're just going to square both sides. On the left side, you'll get x squared. On the right side, you'll get rid of the radical, so you're going to have 11x minus 28. But now, we have turned this equation into a what's the word for it? Into a quadratic. We have a quadratic expression. And so we're going to solve this like a quadratic, meaning I'm going to make this equation so that it's equal to 0 on one side. So I'm going to subtract or add those terms, and I'll do the same thing on the left side. So on the left side, we'll have x squared minus 11x plus 28 equal to 0, and then we can factor this. I think we can factor that. So we're looking for two numbers that will add to be 28 and add to be 11, negative 11, sorry, and multiply to be 28. So I think that's going to be minus 7 and minus 4. And that's equal to 0, so we can use the zero product property. And then that means that this will be equal to 0 when x is equal to 7 and x is equal to 4. So we're going to have two solutions for this one right here. Similarly, for question 10 right here, I guess, do we have to check the solutions here? So if I plug in 7, I'm going to check both of them, make sure that they're solutions. So if I plug in 7 into the equation, I'm going to get 77 minus 28, which is going to be, and then, so if I plug in 7, right here and right here, I'll get 7 is equal to the square root of 49, and the square root of 49 is, yeah, it'll be 7. Then if I plug in 4, I'll get 44 minus 28, which will be 16, and I'll plug in 4 right here. So yeah, so both of these will work actually. So there you go. All right, for 10, we'll do similar. We're just going to square both sides. So then we're going to get y squared is equal to 2y plus 3. These terms right here, I'll subtract so that the right side is 0. So we'll get y squared minus 2y minus 3 equal to 0. And then we'll see if we can factor this. So what are two numbers that multiply to be negative 3? So it's going to be y minus 3 and then y plus 1. Those are the, so right? I think that's right. Because that will give me y squared. You'll get plus 1y minus 3y. That gives you negative 2. Yeah. Okay, so then we get y is equal to 3, and we'll get y is equal to negative 1. However, this can't be a solution right here. Because if I put in negative 1 right here, I'll get negative 1 equal to the square root of 2 times negative 1 plus 3. Which, again, you're going to have a square root equal to a negative number, which we don't want. Okay, so we are, so just 3 is the answer. So this is called an extraneous solution. So extraneous, I don't know how to spell extraneous solution. An extraneous solution, so basically, like we showed right here, whenever we're solving this square root equation, we end up getting a quadratic equation. A quadratic can often have two solutions, like what we see here. But that doesn't mean that the equation that we started with doesn't mean that those solutions that we find for the quadratic, so these two solutions are the solutions for this quadratic, but they also work for the solutions of this equation here. Same thing here, we get solutions for the quadratic, however, not both of them don't actually don't work for the equation, so that's why we call it extraneous. There's extra solutions that aren't needed, so this is extraneous. So maybe remember to check those. So for 11, we're going to, okay, this one's going to be slightly more difficult. We're going to square both sides. Now on the left side, you have to remember that this is a binomial. So whenever you square a binomial, it has to be multiplied out like this. So this will turn into w squared minus 6w plus 9. And then that will be equal to 5w minus 21. Still a quadratic though. So we're going to do the same thing that we did up here, just move terms so that on the right side it's equal to 0. So subtract 5w and add 21. Subtract 5w and add 21. So we'll get w squared minus 11w plus 30 equal to 0. And I'm going to factor, so w, I think that turns into w minus 5 and w minus 6, I think is what that will factor out to. So you get w is equal to 5 and w is equal to 6 as the solutions. Now you just have to make sure that whenever you plug this into the original equation, that you don't get a negative number. So like if I plug in 5, I get 5 minus 3, which is going to be 2. So that one should work out. That also means that if I plug in here, I can get the, what, that's going to become 5 times 5, 25 minus 21, which is going to be 4, and the square root of 4 will give me 2, so that checks out. If I plug in 6 right here, I'll get 6 minus 3, which is going to be 3, and it's positive, so that's good. So both of those should work. None of them are extraneous. For 12, very similar. We're going to follow the same process. We're going to square both sides. So that means on the right side, we'll get 29 minus w equal to, you have to, so w plus 1 and w plus 1, that has to be multiplied out. So you get 29 minus w equal to w squared plus 2w plus 1 whenever you multiply this all out right here. And then I'm going to subtract 29 and subtract 29 and add W and add W. So then I'll have 0 on the left side. I'll get W squared plus 3W plus 28. Minus 28, sorry, minus 28. Then I'll have to factor, so I'll get W plus 7 and W minus 4. So I'll get W is equal to -7, and I'll get W is equal to 4. Now we just need to check these. So if I plug in -7 on this side, I'll get -7 plus 1, which will give me -8. And I don't want this side to be negative because the other side's a radical. So this is an extraneous solution. If I plug in 4 right here, I get 4 plus 1. That gives me a positive number, so that one should be just fine. All right, for 13. Yes. Let's see, I think we're just gonna... Let's see, are we gonna square both sides? Try and think of the best way to do this one right here. Maybe we do just square both sides. All right, let's do it, because the tricky part here is that no matter what, we have this term. So it's going to be positive 1 over here or negative 1 over here, but on either way we do it, we're going to have a radical and a non-radical, a number that's not a radical. So I'm just going to square the right side and square the left side. The left side is no problem, because that's just going to be v plus 15. But on the right side, that's going to be equal to the square root of v plus 1 times by the square root of v plus 1, which is not so nice. So we're going to have to FOIL this out right here. So I'll do square root of v times the square root of v, and that's going to be equal to v. I'll do the square root of v times 1, which is going to be plus square root of v. Then I'll do 1 plus the square root of v, which again is going to be plus the square root of v. Then I'll get 1 plus 1, which is going to be plus 1. Now these can combine. So I'll get v plus 15 equal to v plus 2 root v plus 2 root v plus 1. And I think what I want to do now is get this radical all by itself. I think that's what we want to do now. This is definitely a long question right here. So I'm going to subtract, oh, there you go. That's actually pretty nice. So I'm going to subtract v from the right side, but I'm also going to subtract v from the left side. So those actually just cancel together. Oh yeah, this is actually going to be very nice. And then I'll subtract 1 from both sides. So on the left side, I should just have 14. And on the right side, I'll have 2 root v. Then I'll divide by 2, both sides by 2. So I'll get 7 is equal to the square root of v. And then again, I'm just going to square both sides. So then I'm going to get 49 is equal to v. Okay, that one's definitely a tough one. And I think we're going to have something similar here. We're going to do the same thing here. And it's going to be a very similar process. We have radicals on both sides, and there's really nothing we can do about it. So the best thing to do right now is just to square both sides. So on the right side, you're going to get 9 minus the square root of y times by 9 minus the square root of y. I accidentally wrote plus. Okay, and that's going to be equal to y minus 45. So I do have to FOIL this left side. So 9 times 9, which is going to give me 81. 9 times negative root y, so minus 9 root y. But then I'm just going to get the same thing whenever I multiply the middle terms, so negative 9 root y. And then I'm going to have negative square root of y times negative square root of y, which is going to be positive y, equal to y minus 45. Now, these terms add, but when I subtract the y from the left side, I also subtract it from the right side, so there's no y's right there. So on the right side, I'll have 81 minus 18 root y equal to negative 45. Then I'm going to subtract 81 from both sides. So I'll get negative 18 square root of y equal to, so negative 45 minus 81. So that's going to be negative 126. Then I'm going to divide by negative 18, divide by negative 18. So I'm going to get the square root of y is equal to 7, and then I'll square both sides. And then we'll get y is equal to 49. Okay. Those ones take quite a bit of time. So 13 and 14, just remember those ones are going to take some time. For 15, solve the equation for h. So we want to get h by itself. So we'll have to square both sides in order to get rid of the radical because the h is in the radical, and that's where we don't want it to be. So we're going to get 4 is equal to t times h. Then I'm just going to divide both sides by t. So I'll get h is equal to 4 divided by t, and that should be an appropriate answer right there. Do the same thing for 16, solve for the variable d. This time though, I'm going to have to divide by 5 first, so divide by 5. So I'll get the square root of d is equal to a divided by 5. And then I'm going to square both sides. So on the left side, I'll get d is equal to, I'm going to use the property of exponents, so square the top and the bottom. So a squared over 25 whenever you square top and bottom. For 17, okay, this one's going to be a no solution. You can tell. So we talked about how if the right side is negative and the left side's a square root, it's no solution. But but that doesn't just apply to square roots, that applies to any root that is even. So we have a fourth root, and yeah, so it can't be negative right there. So no solution. For 18, now for 18, that's different. We have a cube root on the left side and a negative number on the right side. That is okay. If it's an odd root with a negative, that's fine. So in this case, though, I'm going to cube both sides. So we're going to cube it on the left side, that's going to become y. On the right side, that's going to become negative 8. And that is just fine right there. For question 19, all right, now we do have a negative number on the right side, but this radical is a cube root, and that's okay. So we can continue to solve this like normal. So on the left side, I'm going to cube it. I'm going to cube the right side as well. So I'll get 5w plus 12 equal to negative 8. Subtract 12. So I'm just going to solve this like a linear equation. So I'll get 5w is equal to 20. Then I'm going to divide both sides by 5, and I get that w is equal to 4. That's supposed to be negative 20, so this will become negative 4. My solution is negative 4. For 20, we're going to cube both sides. So we'll get 4v plus 7 is equal to 7v minus 2. Then I'm going to subtract 7. No, I'm actually going to subtract 4v from both sides because I want v to be positive. So those will cancel right there. And then I'm going to add 2 to both sides. So on the left side, we're going to end up with 9. On the right side, we're going to end up with 3v. And then I'm going to divide both sides by 3. So I'll get 3 is equal to v. All right, for 21, we have equations that have rational exponents. But remember rational, so we have a cube. This is a raised to the 1/3. Being raised to the 1/3 is the same thing as the cube root. They're the same operation. So I can solve this just like I would with radicals. So I can just cube the left side and cube the right side. On the right side, those multiply to become 1. So on the left side, I'm just going to have u. And on the right side, that's going to become negative 8. For 22, now for this one right here, it's a fourth root because it's to the power of 1/4. And on the right side, it's negative. So remember what we said, that if you have a fourth root or an even root, a square root, a fourth root, and the other side is negative, then there is no solution. No solution for those problems. For 23, we are going to cube both sides since we have a power of 1/3. That's going to end up being 6x minus 6 equal to 8x minus 2. And then I'm going to subtract 6x from both sides and add 2 to both sides. So I'm going to end up with -4 is equal to 2x. I'm going to divide both sides by 2. I should get x is equal to -2. For 24, we're going to solve for this part right here. So first thing I'm going to do is subtract the 3. So I'm going to get 7u plus 11, that's raised to the 1/4. That's going to be equal to 3. Then we're going to raise both sides to the 4th power. That's going to be 7u plus 11 is equal to, what is 3 to the 4th? I think that's 81. 3 raised to the 4th, that's going to be 81. Okay, and then subtract 11 from both sides. We'll get 7u is equal to 70. We'll divide both sides by 7. And we get u is equal to 10. Okay, that should be everything that you'll need to help you on your homework.